Hello everyone, it's March 26th. We had a very bad one yesterday, it took us 2.5 hours. So today, let's see if we can seek some revenge. Alright, if we're ready, let's go for it. Word subsets. Okay. Ooh, I don't feel good about this. Let's take a look. We're given two arrays, A and B. Okay. They LeetCode align themselves with all the other companies, right? Each word is a string of a lowercase letter. Okay. Now say that word B is a subset of word A if every letter in B occurs in A, including multiplicity. For example, this is a subset of warrior, but is not a subset of... Wait, what does multiplicity even mean? I saw the word, I saw it previously, but I don't really know. Let's check multiplicity. Multiplicity does it mean? It means the quantity be multiple of various. If a member of multiset number of times appears in the multiset. So it means it can appear multiple times. I think that's what it means. Now say a word A from A is universal if for every B in B, B is a subset of A. Return a list of all universal words in A. You can return in any order. So B is E and O. So it doesn't have E, we have O. No, we have E, we have O. That's good. We have O and E, O and E. So okay. L and E, LeetCode. E and OO. So Facebook and Google. Yeah. LO and EO. LO, LeetCode, and then Google. Okay. EC, OC, and CEO. Okay. Alright. Alright. I mean, basically it just says it could be any place. If you look at this, OO, EC, it could be, no, EC has to be together, right? No, EC, it doesn't have to be together. So it can be like any place. Yeah, like here, like WRR, A is in between, so it can be any place. Same thing, EC, E is here, C is here, so they can be any place. OC and CEO. So it seems like, I mean, you have A length and B length, both are 10,000. And AI dot length and BI dot length is smaller than 10. Both consist of lowercase letters. All words in AI are unique. There isn't I, so okay, so they're all unique words. And then we just need to see if all of this can fit inside a word, right? Okay. Let's see. Well, we have to loop through. I have looped through this. We'll check every word. Check this, this, and this. All right. I'm just thinking about. I think this is going to time out. Like for each of this, we can, because we don't care about order. We don't care about anything. So they can be turned into a counter, right? This will turn into a counter, and then this will turn to a counter as well. So we just compare. We just see if they match, right? Basically, we say if we have to loop through every single one of these and see if they match. If the number of repetition here is smaller or equal to the number of repetition here, and then that's a match. But the problem of doing this is for each one, so we're looking at O, N, M, where we multiply these together, and then times 10. So if we do a 10,000 by 10,000, this is going to time out, no matter how you look at it, it's going to time out. So if it's going to time out, what can we do to avoid it? I mean, we want all of these, right? We want for every B in B, and B is a subset. So I want this to be a subset, this to be a subset, and this to be a subset. And they have like similarities, right? So basically, if we look at this, what we want to say is we want an E, we want a C, we want an O, we want a, that's it. Because if we satisfy CEO, we will satisfy OC, we will satisfy EC. So these three can be combined into CEO. So we only need to compare CEO to each one of these. So that is ON, significantly smaller, right? And for here, well, LO and EO, so we just need to satisfy LOE, right? We satisfy LOE, and then we're good. Just satisfy EOO, LE, and EO. So we need to combine B together. Now, when we combine it together, if we have repetition in a single word, that has to count. But if we have repeats in the second one, then we do not need to count. So basically, we're going to turn that into a counter, turn B into a giant counter. So each one will be a counter, and then we put this into the counter. Like if it exists, yeah, for each one of these, right? We're gonna for each one of these, we check if it is. If it exists, then we don't do anything. We turn this into a counter, turn this into a counter, right? And then we merge them, right? We merge them. Now, how do we merge them? If we take the large one, right? We take the large one of the two. All right. I think we have one. We have a solution now. Let's try it. I'm gonna copy from this. Now this is usual routine that we do. All right. Take a look here. All right. What do we have? Is the same old. Delete this and put this one in. Okay. All right. So we're gonna modify B first, and we need counter. So we're gonna say from collections, import counter. All right. So we're gonna say CB equals just a counter, right? With nothing. Actually, we can say B0, right? CB and B0, and then we say B4. Let's say for I in range 1, 2. Well, actually, let's just do this. I mean, it's fine. So I don't have to do this. I can just say for B in B, right? And we say, oh, CB, and I change the name. Overall, CB all, right? And then this one is CB equals counter B. And then we're gonna say CB all for key value in key count in CB.items, right? We're gonna say CB all key equals CB all key and count. We take the maximum of the two. So that's to handle the B, and then we're gonna say res equals this, and for A in A, right? And then we're gonna do CA equals counter A, and then we say for KC in CBO.items, right? CBO.items, and then we say if CA counter A K is smaller than C, then we break, which means we cannot do. Otherwise, else, which means everyone is larger or equal to C, which means we have found it, then res.append A, and we return res. Okay, let's try the test cases. We have quite a lot of test case to work with, so that's a good thing. Oh man, we have to fix all the unfortunate. We have a lot of things to fix here. So first of all, fix all the quotes, and then we have a bunch of this to fix. All right. So 2, 3, 4. 4 test cases. Second one is L and E. L and E. Third one is E and OO. Next one is LE, LO, and EOO. Actually have one more, I think. Yeah, do have one more, which give us EC, OC, and CO. And we also have to include the answer. So the first one will be Facebook, Google, and LeetCode. I have to sort them just in case my solution is not exactly the same. Next one is Apple, Google, and LeetCode. Next one, they definitely think very high of themselves. That's funny. Think about it. All right, next one, Google, LeetCode. The last one is Facebook and LeetCode. Well, LeetCode almost is in every single one of them. All right, forgot to put this. Now we're gonna say have A, B, and answer. Res equals word subsets A and B, and we're gonna say instead of res sorted, res equals sorted answer. Is answer sorted already? Yeah, I think answer is sorted already, so I don't have to sort answer. Run it, pass every one of them, and we're going to try. Submit, pending, judging, accepted. All right, I consider this as revenge success because today is 13 minutes. Okay, let's write some comments. The key observation is that we do not have to examine each B in B because there might be overlaps among the B's. If 2B have overlap, have letters, have common letters, that letter only needs to be checked once. Therefore, we first condense B into one item for checking by merging B's via their counter version. We say we keep the maximum counts of each letter in the final merged counter. Then we loop through each word in A, get its counter, and compare the A counter with the merged B counter. The rule is that the letter count in a counter must be bigger or equal to the same letter count in the merged B counter. All right, so this one will be O. Let's see, what's this? So this is let's call B as N, right? So it will be N, and then it's going to be the counter will be the, let's call it N plus, right, M for every single one in A, and to do this is M, and how about this one? So we can say this one plus maximum 26, right? Maximum 26. Just put 26 here, right? Where M, N is the length of A and B, and M, N are the average length. And this shouldn't be 26. It should be, it's hard to say. I just say the max length of letters of the max number of letters in the words of A and B, and 26 is the maximum number of letters in the merged B counter. We run in, what is our runtime? Our runtime is, wait, no, I can't click on the wrong one. It should be this one. Runtime, oh, it's not too good, which means there are better solutions. Our runtime is 904 milliseconds, which gives us 52% ranking. This one has a very wide spread. Let's see what other people have. Can you like optimize it? I don't know. I think it's pretty optimized, unless that there are better ways to do this. I don't know. I don't think so though. All right, let's take a look. Medium question for sure. Yeah, this is a typical medium question. I mean, medium question have different levels, and this is definitely an easy medium question. All right, let's take a look. A plus B, total length. Yeah, which is fine. Okay, so go for Python solution. Oh, it's simple. I don't want to read this. I want to just see this directly. So count word. Oh, that's a counter. Okay, so that's a counter. B max. Oh, it's the same as us. We create a merged B counter, right? For counter B, and then B max I. Yeah. There goes max. Yeah, it was the same thing. And then answer. We are going to zip counter A. Huh. Okay. Okay. Yeah. We use this. You can do that. All right. Yeah, it's the same. It's the same solution. Exactly the same solution, but they just use a slightly different implementation. They don't use a counter. They use an array, but it's basically the same idea. It's the same idea. All right then. That's good. That is, what the hell is this? Somebody put a, bless you. All right. That's it. Good. Did a good one. Straightforward. They're all from 2018. Huh. You use counter? Oh my god. Oh. Oh my eyes. My eyes. What the hell is this? Ooh. What is this magic? Counter I can do or. Huh. What is this magic? I do not know. Alright, let's take a look. From collections, import counter. Right? So the C is going to be a counter. Let's say C going to be a counter of ABC. Okay, so that's C. And then we're going to say A is going to be a counter of AA, B. AABB. Alright, AABB. Okay, so we do A or C. What do we get? Oh my. This is interesting to say the least. Python counter or operator. I don't know if they have this. Oh. So what does that mean? Like, man, these are useless. Let's try Google. See Google if Google has some better solutions. So Python counter or operator. Is that how you search for it? Oh, dang it. No. I think we need to go to documentation, but let's take a look at this. They probably will provide something. Items like that, values, addition. Okay, I think they probably have addition of two counters. Creates in additions of values according to each key, and if a key pressing one counter not in other keys is also given the final output. So we have this, right? A, B, okay, G. Where's G? Good. Okay, that's add. Subtract from each other and it keeps only the positive. What if the ones that do not exist? So if we do counter 1 minus counter 2, if counter 2 doesn't exist, we use a counter 1. How about then if it's counter 2 it exists, but counter 1 doesn't exist, and that one is gone. And if both exist, we're going to take the difference. For example, the B. No, wait, where is B? Well, B is 2, and B is 3. I don't see B here. Oh, because it's a negative. Once it's a negative, it's gone. Oh, so if it's a negative, it's gone. Okay, that's the rule. But if it's a positive, it gets kept. Alright, end of two counters is intersection. Oh, typo here. Only the minimum of corresponding counters. Counts min. Okay, so and is doing min. Nice, which makes sense, right? So it's and, so we take intersection. Union, or is taking a union, which is the max. Can I like it? I don't want to sign it, but okay, this is very good. This is very good. and then we do counter minus this, right? If counter minus this give us some result, that means oh yeah. So if it contains inside here, so this one shall give us a empty counter. So if not, ooh, good solution. Who submit that? Very, very good solution. Very, very good solution. Damn. This is good. All right, I'm gonna comment on this one. Very good use. No, I should say, learn something. Ah, very good solution here. I learned something new. The union and intersection, of course. This is a union. The union of counters. Very good. Very, very good. How about this one? Man, when I see reduce, oh, it's the same thing. Same thing, I reduce it, okay. After reduce it, what is this? Counter this one and this one. So, and we take the mean. We take the mean, shall be this. Good, that's also good. I'm going to write this one. This one is more intuitive, shall I say. Very, very nice. All right, let's take a look at this response. What did he say? Same here. There's nothing. Ha! Interesting. All right. Anyway, we saw some very smart solution. It's good. You know, you learn something, right? You learn that. Yeah, you learn this. This is good. This is very good. All right. The counter has this magic. So basically, it's the same solution, but with some counter magic. Okay, so we have solution 2. I'm going to say link found. This counter magic solution from the discussion. Very cool. Yeah, this is like indeed very cool. Maybe it has even better runtime. I don't know. All right, let's try to write it ourselves. So what we're saying, we're not going to use. We are not going to use reduce. We're just going to say this, right? And then we're going to say for B and B and CB this, or and counter B, right? And then we're going to say return A for A in A if if CB all, we do minus, right? Minus. If I minus, the result shall be empty. So minus counter A. if not. Right, so that is the two pieces of magic. I don't have to have a line, right? The two pieces of magic is one, counter union, and two, counter subtraction. Read here for their usage. I'm gonna post the link from Geek for Geeks. It's pretty clear what they do. They did a pretty good job. So, okay. Now we're going to submit this and just take a look how this one fare. I think this one shall fare pretty well. Actually, I haven't run it here. Let's try it. Yep, it's good. So submit. Well, when you see this, it doesn't want you. Oh, that's a bad runtime. It does make you want to use reduce, right? Yeah. Anyway, that's it. That's good. Good. We did it good today. Very well. All right. We have revenged from yesterday, but still things that yesterday shouldn't happen. It should not happen. All right, that's it for today. Let's keep fighting tomorrow. I'll see you guys tomorrow. Adios.